Our next speaker is Eylül Turan from KU Leuven.
Hi everyone. Today I will present my second project of my PhD, which is supervised by Berthe Schmidt. And I will be talking about mathematical language and mathematical abilities in monolingual and multilingual children. So mathematical language has gained a lot of interest actually in the recent years, and it has been found to be an important correlate of children's mathematical development. And mathematical language basically refers to the keywords and concepts that are required for mathematical activities. So examples are, for instance, quantitative words such as a few, more, a little bit, and most. Spatial words such as under, between, above, and near. So importantly, we also have these number words like 1, 2, and 3. But when we talk about mathematical language, we do not really include these terms because these have an additional focus on math knowledge. This is why other researchers in the field and also the current project will not include these number words when talking about math language. So very recently, we conducted a systematic review of the literature on math language and math abilities, and we found correlational, longitudinal, and even some causal evidence for the link between math language and math abilities in preschoolers specifically. One important thing that we noticed was that all of these findings were restricted to monolingual children and mainly to English-speaking children. So one question is, of course, would we see similar associations for children that have a different linguistic background? So I want to give a very brief definition of multilingualism here. This is the case in which a child learns 2 or more languages simultaneously, or when one language is learned first and other languages are added on later on. And it is important to distinguish a multilingual profile from a monolingual profile because it has obviously important educational implications. But it also would lead to important theoretical implications. Basically, it would give us information regarding the mechanisms between language and mathematics, or more generally, language and thought. Okay, so just a brief overview of the evidence that we have for multilingual children. So generally, these children have challenges or face challenges with language skills. They have smaller vocabulary in each language, and this persists from 3 to 10 years of age. And they also have a slower naming speed. So the knowledge base in each language is less rich because they have to activate and use two different or sometimes more languages. As for mathematics, there is very limited evidence in the domain of multilingual children. So some studies report a multilingual advantage, specifically for numerical competencies, whereas others do not report any differences between multilingual and monolingual children. Okay, so we have, of course, some unanswered questions. So for the math language part, one observation is that almost all of the studies looked at these different language categories together. But I mean, these different language types, so quantitative and spatial language, they are not identical. So it becomes important to separate and look at their effects to math abilities like separately and independently. Another observation that we had was that, again, almost all of the studies looked at children's numerical competencies only. However, we know that mathematics is, of course, more than just number. It also includes geometry, measurement, and other domains as well. So it is important to look at these other areas of math abilities. And finally, as I mentioned before, the evidence is restricted to children who show proficiency in only one language, and this is usually English. So this is why in this study we also wanted to look at children who show proficiency in different languages. So we tested 150 children, and the monolingual sample came from a larger project. And these children were around the age of 4 years, and we actually tried to match the children on age, sex, and SES as well. With age and sex, we were successful, but we couldn't match them on SES levels. So monolingual children had higher SES levels than multilingual children. So for the multilingualism questionnaire, we asked parents to indicate the languages that are spoken at home. We asked the mother tongue of each parent. We asked the age of exposure and age of use, including Dutch and the other languages as well. We asked the frequency of exposure and frequency of use of each language. And finally, we also asked the mastery level for each language. And we included children if they heard and also spoke 2 or more languages. So based on the age information, we categorized children into 2 groups. So early multilinguals were the ones who were exposed to each language starting from birth. And late multilinguals were the children who were exposed to the second language, not from birth, but later on. And what we observed here was that late multilinguals, the second language was always Dutch, which was basically the language of instruction. So what probably happened that these children started to being exposed to Dutch once they entered the preschool. And for the task that we used, for the math language task, we used an adapted version of the task developed by David Purpura. So here we had 1 part for the quantitative language and 1 part for the spatial language task. Here, for instance, we would ask the child which box has the most dots. And here we would ask, point to the dot that is under the box. And as you can see, we really try to cover a range of different terms for both these quantitative and spatial domains. Moving on to the math performance tasks, we of course measured children's numerical competencies. So we looked at their object counting, their numeral recognition, and their number order performance. So in the number order, we would say which number comes after 7 and before 7. And for the measurement and also the geometry task, we use a standardized measure, which is called the CITO. So this is a Dutch task that is used for preschoolers. So in the measurement, for instance, here we would ask which cups are equally heavy. And here we would say on which picture are the lines from short to long. And in the geometry, we would ask children some shape knowledge questions. For instance, can you show me the rectangle? And here, for instance, we would say with which shapes can you make this larger figure? And finally, we also considered some general abilities that we know are important for mathematical achievement. So we looked at children's general language. We used the Peabody receptive part. And we also assessed their spatial ability with the children's mental transformation task. So here, children basically had to combine these 2 halves with each other to make a bigger whole. Okay, so this is a descriptive table, and overall what we observed that monolinguals performed better than multilinguals in almost all of the tasks. And we did conduct a Markova analysis controlling for children's SES levels, and here we also observed that monolinguals were better in quantitative language, spatial language, geometry, measurement, and general language. However, the 2 groups did not differ from each other in their numerical competencies and also in their spatial skill. The next step was look at the correlations in each group. So this is a correlation analysis controlling for general language and SES for the monolingual group. And as you can see, quantitative and spatial language do correlate with each other. Quantitative language correlated with all 3 math domains to a similar extent, and spatial language as well. But what we see is that for spatial language, it correlated more strongly with geometry compared to measurement. And when we compare multilinguals to this to these correlations. Again, we have a link between quantitative and spatial language, which is slightly higher than monolinguals. And different from monolinguals, quantitative and spatial language did not correlate with geometry, but it did correlate with measurement and spatial skill. Numerical competencies. And also one other aspect was here that among the math ability variables, geometry and measurement did not correlate in these children. Okay, so the final analysis I will report comes from this early versus late multilinguals. So early multilinguals, so these are the children who were exposed to both languages starting from birth, and these were younger than late multilinguals. But despite their younger age, they obtained higher scores in the general language task and in the spatial language task. So a quick summary. Monolinguals performed better in most of the tasks. And for monolinguals, components of math language were related to different domains of mathematics, and we even observed some differences in the strengths of the associations. For multilinguals, we did observe similar yet not identical associations, and despite their older age, multilingual children who were exposed to the second language at a later age had poorer general language and spatial language abilities. So overall, for monolinguals, we actually did observe clearer and theoretically expected links. And one possibility is maybe for these children, better math language abilities might lead to better math performance. But this is, of course, something to test later on. And this was not entirely the case for multilinguals. So it could be that because of these poor mathematical language, they use different strategies. So recall that, for example, in the geometry task, we didn't observe links with any of the language categories. So maybe these children use different non-verbal, let's say, spatial strategies, given that this task is also highly spatial, to solve geometrical questions. And this is maybe why they do not succeed enough. Okay, and one last thing I want to discuss is about this early versus late multilingual part. So in Belgium, recently, a language screening has been introduced for preschoolers, and this is also being implemented in other countries. And our data actually shows that children who acquired the language of instruction at a later age have difficulties not only in general language, but also with this very specific spatial language. And this, of course, poses another problem, important issue, because we know that spatial language is related to STEM achievement in general, and it's also important for everyday activities as well. And especially for the mathematical context, we also know that teachers usually use quantitative words, and in classroom activities, they usually focus on number activities. So it seems to be important to also maybe focus more on the implementation of spatial language in the classroom setting, because it also contributes to different mathematical abilities. So thank you for your attention. This is my and our group and my contact information, and I would be more than happy to maybe collaborate or to discuss other things. So yeah, thank you for listening.
Yeah, thanks a lot for the interesting talk. We have time for questions. Or comments? Yeah, in the back.
Thanks for the presentation. It's a very comprehensive project that you're working on. My question is about the special ability and the measure that you use for that. I'm also a math educator, so I'm working on just like these issues, and I know that to measure special ability at early age is difficult. So I wonder like about the reliability and validity of your instrument, and also, you think that is that related to the results that you have, because the special results behave differently than the other mathematical ability that you measured? Thank you.
Thank you. Yes, so this task, in my previous study, I used the 10-item measure, and that one had a low reliability, like 0.40. For this one, I used a larger, like a different version that has 16 items. But as you said, the reliability is still not very high. It's 0.55. But the reason I wanted to stick to this measure was because, like, mental rotation, we know that it's very related to different mathematical and cognitive areas. And yes, I mean, I wanted to continue with this measure because, for example, with other measures, for instance, the block play, this is also used a lot, but it's also has this like motor component. So yeah.
More questions, comments?
Hi, it may be a silly question because it's not my domain of research, but I was wondering so you asked the tasks were linguistic, right? That you instructed kids in a language, and this was their second language for multilinguals?
Yes, so it was all Dutch.
And are there studies, or have you thought of trying to explain the tasks in their native language to see how they would perform then?
Yes, yeah, that's so that was actually something that we thought about a lot, because in Belgium there are also French speakers, a very big part. So there is a high proportion of children who really are bilingual from birth. But then we decided, I mean, yes, probably in their mother tongue, maybe like they would perform better. But we wanted to, like, in order to compare monolinguals and multilinguals with a single language, we decided to stick to Dutch, because the problem is also, for instance, in the math language part, let's say in English, we have these words like a few or like least that has a distinction between like continuous amount and like concrete amount. But in Dutch, there is only one word, that is minste. So that's why we didn't want to interfere the design by using like different languages. But yeah, I mean, I do think that, yeah, maybe in the language that they have mastered better, they would perform probably better.
Hi, thank you. Just in line with this question, also I was wondering about the profile of the multilingual, because there's this maybe more bilingual profile of Dutch-French with families that probably have with generations of living in the same place and being more established, etc., and the type of immigrant background multilinguals. I wonder if you checked that.
Yes,
Thanks.
yeah. So there was definitely I think it was maybe more immigrant backgrounds, and like the issue of SES was also definitely, I think it definitely affected the data as well. So yes, I mean, also, for example, for especially like with these late multilinguals, these were all immigrants that came and then they learned Dutch because the children entered preschool. So they actually were exposed only to Dutch like when they were 3 or 4 years of age. And yeah, I think SES and immigrant status would also definitely have a huge effect.
Okay, so we have time for one short question.
Yeah, so following along from one of the questions just before about what were the linguistic profiles of the multilinguals, because you're talking about how certain languages have different kind of conceptual mappings for these concepts. Have you investigated whether children of certain language backgrounds who have different concepts of those mathematical categories would perform differently than others because the concept is inherently different? So if you have this very tight word that means a lot of mathematical concepts in one language, but in others it's quite abstract, children may perform differently because their linguistic profile is different, not because they're unsuccessful in your task, if that makes sense.
Yes. So this is something I will hopefully investigate in my next study. Because, for example, I'm Turkish, so in Turkish for geometry, we have a structure in which we would say dörtgen, and dört already means 4 corners. So it's a much more transparent language if you compare it with English. And I do think, for instance, children who have this, let's say, linguistic advantage for these terms probably also are more familiar with them, with these terms. So, yeah, I mean, hopefully I will present that work as well at one point. But yeah.
Okay, let's thank again the speaker.